This lesson is on the integration of the reciprocal function. I'll explain that really soon. Actually, I'll explain that now. So essentially this, but there's more to it than just that. And so that's why the learning goal is integrate fractions. That's the real big one. So integrate fractions by recognizing the derivative of the function of the denominator on the numerator. Okay, so I'm going to unpack that a little bit more in our next slide, so might as well go there, so press pause if you have to. Okay, so we've got a fraction here, and normally I would say, alright, if it's a fraction, change it to an indice. So let's do it, we change it to an indice. We still haven't integrated yet, okay, and now I'm like, oh yeah, sweet, I can just integrate that normally. Let's increase the power by 1. X to the 0, and then we divide by 0. But then we realize that there's a problem there. And the problem there is this 0. We can't divide anything by 0. So we have to go back to the drawing board and figure out another way. Now, by the time you get to this lesson, you would have already figured out that the derivative of log to the base e of x is the reciprocal function 1 over x. Okay, so the integral of 1 over x is going to be log of x, and that's actually true. I'm going to write this as ln x, and then because it's an undefined integral, there's no, I didn't put 0 there, we're going to have to go plus c, so the antiderivative is plus c. But if we look over here, this is from our formula sheet. And what it says is that if we've got a function here at the bottom, then if we have its derivative, then it's going to be log of that function. And let's unpack this in this one a little bit more. What is the derivative of x? Oh, it's just 1. So this formula works, okay? Because what was our function in the bottom? It was just x. Okay, so have a bit of time to think about that, because it's probably a bit more. Now we're going to be doing that more so in the next couple of slides. Okay, so here there's two ways we can approach this. Okay, well, if we look at our formula sheet, forget about the derivative of log to the x is 1 over x at the moment. We've got this statement. If we've got a function and if it's got its derivative, we can just put the function inside there. But what is the derivative of x? Well, it's just 1, and you would be true. So there's two ways that you can approach this next question. The first way is, remember, we can take any constant, no variables, any constant outside of the front of the integral sign. Okay, that solves our problem pretty simple. We go 5 times log x, and it's going to be plus c, so that will be 5 log x plus c. So that would be one way of doing it, okay? And that would be the best way of doing it. Now, I'm going to leave that question up there, so make sure you write that down. I'm going to tackle this next question, okay? Now, I look at this and I'm like, and this should be dx here. Apologies for the mistake. So make sure you write dx, because otherwise it's not an integral. What I want to do is, I'm looking at this fraction and I'm like, oh yeah, I can, don't write this down by the way. Change this to an indice. And then I realize, oh, 1 more than -1 is 0, so that won't work. So I have to start again, and then I remember my log function, okay? And I go, well, if I have a function at the bottom and its derivative on the top, I can use this log thing. So I look at this and I'm like, oh, it doesn't really work. But I'm going to tell you it does, okay? So I'm going to give myself a bit more space. I'm going to go equals, and I'm going to put my integral a little bit inside. Hopefully you see it by. Oh yeah, actually I don't need that integral. Oh yeah, I do. So what's the derivative of that's in green? Now, most of you are going to shout out and put -2. Okay. Well, what I'm going to do is I'm going to put -2 at the top of my fraction and put 1 minus 2x at the bottom. Now, all I want to do now is multiply it by a constant. I'm going to choose a different color. That's going to cancel out, so I'm going to multiply by 1 over 2, because when I cancel out, I'm allowed to do that. I'm allowed to multiply by any constant. And if I cross out here and these negatives, I'm back to 1. Okay. So all I'm doing is compensating by putting a constant out the front. I can't do that with an x. I can only do that with a number. Okay, and -1/2 is certainly a number. Hopefully that makes sense. That's the tricky part about this lesson. And now I've got the situation where I have the derivative on the numerator of the function at the bottom. So that equals now 1/2 log, and remember, it's the whole function that's inside, so it's this whole thing. So it's going to be 1 minus 2x, and because it's an indefinite integral, I'm going to go plus c. Spend a bit of time on that to see what I'm doing. What I'm going to do is I'm going to do another 2 questions that will rely on this a little bit more. Okay, next one is that now we've got a bit higher powers, but it's pretty obvious that the derivative of the bottom is at the top. Okay, so I can go straight to my answer. Log, what's our function? It's all that. So it's going to be x squared plus 2 plus c. So pretty straightforward. Okay. My next example, we'll look at this. What is the derivative of that? Oh, that's going to be -6x. Okay, let's try play around with it and see if we can get something going. So I know what I want to get at the top, so I'm going to put that in now. Derivative of the bottom would be -6x. Alright. Now that's not what's here, but what constant can I multiply it by to get that? Well, I need to get 1 back at the top, so I'm going to go 1 over 6, and there's a negative there, and then I'm going to put that out the front. Well, now I'm set. So let's do the answer. So it's going to be -1 over 6 log of our function in there, which is 1 minus 3x squared plus c, because it's an indefinite integral. Alright, so this is actually a very important theorem. Okay, there is no quotient rule for integration, so the first go-to is let's change it to an indice. When that doesn't work, we look if the log situation will work out. Hopefully it's all very clear. Peace out.